I think 10th lecture, and electrostatics. We are discussing the electrostatics part, in which the topic is electric dipole in the uniform two-dimensional electric field. Basically, we have put the dipole in the uniform electric field. The dipole is here. I have represented the negative and the positive. And dipole is nothing but the two equal and opposite charges are separated by the some distance, small distance, and we generally take this distance as 2a. 2a. We in this topic we are going to find out the torque related to the, because electric field electric field, when in charge on the in the electric field, it experience a force. This force is nothing but E in Q into charge into electric field, because electric field is in this direction, then the direction of the electric field, yeah, the force is in, let's suppose I take this in the x direction, and the negative direction, the force direction is opposite to the electric field, then it is in this direction. Simply I write as QE, and basically it is the uniform electric field. Then body will rotate, yeah. Basically the body will rotate on a fixed axis, on this axis, and the force is zero. Remember it, when we have the uniform electric field, the force on the dipole is zero, but torque is non-zero. We are going to find out the torque on the this dipole. We What is the difference between the force and the torque? Basically, when the body rotate, we deal with the torque instead of the force. Then let's suppose, we have to suppose that this is the theta angle the dipole is making, because dipole has the direction from the negative to the positive. P, we generally write it as the p vector, and then this is the electric field direction, basically. And then the torque is, I have to write the torque. For this I have to go to the next slide, and then torque is nothing but, remember it, the magnitude of the either forces
force into
torque is nothing but magnitude of the either forces into you have to take the magnitude of the force and perpendicular distance between the two force direction. uh, just we have to find out the this perpendicular direction, this perpendicular direction we have to find between the two forces, and this is nothing but, this is also theta, and this is, then I write the this perpendicular distance is nothing but 2a sine theta, yeah. Basically it is perpendicular. Basically you can also evaluate from this, sine theta is according to the sine theta, it is perpendicular by hypotenuse, and then perpendicular value we have to find out the p. Then p is nothing but h. H is hypotenuse is nothing but the 2a value, and then sine theta. Yes, I have written this only, 2a sine theta, the perpendicular. And basically, and the force is, we had to take the just one force, basically. And then this is QE, and then the torque become the magnitude of the either forces is QE, basically, and into QE. Torque is a vector quantity. Basically I deal with the only the magnitude. I just rub it out the vector part, and into simply it is a simple product, it is not a cross product. And then perpendicular distance is 2a sine theta, yes. And basically then sine theta, and then p vector is nothing but 2a q, yes. Dipole moment, and this is then it become, if I put the value p into p into e sine theta, yes. Then you must know that the cross product, the we can change into the cross product, then it become e cross e. Now it is I would say now first, this is the cross product, okay, remember it. A cross product between the p and e, it is now I can represent it by the torque quantity. And you must know the torque cross product between the two vector quantity is nothing but the magnitude of the e into magnitude of the b into sine theta, okay, the angle between the two vector quantity. And you should also remember that angle is nothing but the between the uh, two tails, okay. Just also remember this part also very important. And then the torque become the p cross e, remember it. You can also take some of the special cases when the theta become 90 degree, then the pe we get the torque as pe. Simply torque is equal to pe. And if theta is equal to 90 degree, yes, then the sine theta become 1. And simply, and if the theta is 0, then the torque is 0. You can also see from the this also. Let's suppose if the theta is 0, then the dipole is in this direction only, then the force is equal and opposite, yeah. If the dipole, let's suppose this is the dipole and theta becomes 0, then the force on this is QE, and force on this negative charge is minus QE. You can as represent, you have already represented the direction, just simply write the magnitude. Then it is in the equal and opposite, they are equal and opposite direction. And then we simply say that they will cancel out, and this equation is also showing that only the basically the torque is equal to 0 when the theta is 0, simply. Okay, thank you.